Today's lesson is about Booleans and decisions. So let's start taking a look at some Booleans to start things out. If I take a number like 7, we had a sign before and we'd say x is equal to 7. Now there's a little bit of a different sense in computing with the notion of comparison. Is the number x equal to 7? So notice the difference between these two. We've got x is assigned the value of 7, and then we ask the question, is x equal to 7? Does x have the same value as 7? And so when I press enter, we've got x was initially assigned the value of 7, and then we ask the question, is the value of x 7? And Python replied with true. If I had asked the question, is x equal to 9? Remember, x has a value of 7. The double equal sign asks the question, are the values the same? Here, of course, we'll find out that the values are different. So this notion of true and false is known as a Boolean value. And so now we have a new type. So the type of true is bool, short for Boolean, and the type of false is also a Boolean value. With this notion in hand, we can now ask questions such as, is a number even or not? And of course, what's the definition of an even number? Well, if you divide the number by 2 and the remainder is 0, then it's an even number. So for example, if I find the remainder, remember the percent sign tells us the remainder when we do integer division. So if I find the remainder when I divide 8 by 2, we see that the remainder is 0. Similarly, if I did, I said, okay, what's the remainder if I divide 7 by 2 and I get a value of 1? The remainder is 1, therefore it's not an even number. In fact, it's an odd number. So let's put these two concepts together. We can now ask a question, is the value, if I take x and I find the remainder when I divide it by 2, is that value equal to 0? And since x, the value of x was 7, we divided by 2, the remainder was 1. 1 is not equal to 0, so that question returns an answer of false. Let's take a new number. Y has a value of 6. Let's ask the question. If I take y and I divide it by 2, look at its remainder. Is its remainder 0? The answer now is true. So with that notion in mind, I can now actually start looking at choices or decisions, and I can say something like this. If when I take y and divide it by 2, its quotient, if that quotient is 0, then I can print y is even. Now notice what happened here. We said if, and then we had y percent 2, the remainder of y divided by 2. So we did that calculation. We came up with 0. Then we asked the question, all right, is that remainder equal to 0? It was. So the whole value of that expression was true. So that expression is true, and we printed it. If, on the other hand, I said if x percent 2 is equal to 0, so the remainder when I divide x by 2, I'll say print x is even, then we see that nothing is printed because x was odd. Now there's a little bit of syntax here. You'll notice the coloring. So if, that's a reserved word. We had our expression, which is in black, followed by a colon. So that indicates the end of the if part of the expression. And if that expression is true, then we will do the statement that follows. With that, we can actually take a we can actually write a little program. So what this will do is this program will ask for a number and tell us whether it's even or odd. So let's ask for some raw input. Remember, input comes in as a string. Enter a number. I like to leave a little space in there. And we have to convert that number to an integer. Because we're going to be working with this as actually wanting to be working with the numbers. So now I have an integer. And I can ask the question, if that number, when we divide it by 2 and get the remainder, if that value, if that remainder is 0, I will print the number is even. And we'll save it. So let's take a look at what we've done. We print out a title, even or odd. We ask for an input, convert the input to an int. Now we can ask a question. If, when I divide the number by 2, its remainder is 0, we will print the number is even. Let's try it out. So we enter a number, and let's put in the number 8. It says the number 8 is even. Notice on the print statements, everything is, we print things separated by commas, so we get the number is printed. That's what's between quotes. The actual words the and number, comma, number, that's a variable whose value is 8 in this case. And then again, we print a string is even, period. So strung together, we get the number 8 is even. Let's try it again. Let's give it an odd number. It prints nothing. It would be nice to fix that up a little bit, and we can. It would be nice to print something if the number was odd. Well, since numbers are either even or not, even or odd, we can say, well, if the number wasn't even, it must be odd. So let's print the number is odd. And now let's try that out. Taking a look at it. Now, if when we divide a number by 2, its remainder is 0, it will print the number that it's even. Otherwise, if it's not even, must be odd. So let's print that it is odd. So we will run this one now. Again, if I give it an 8, it tells us that it was even. All right, that still works. And now let's give it the 5, and now it in fact tells us that the number is odd. Now we could completely reverse the sense of this, because maybe I'm thinking, all right, if the remainder is 1, then the number is odd. Otherwise, it's even. So now I've just simply reversed the sense of it. The logic actually is exactly the result should be the same, and let's give it a try. So if a number is, we'll give it a number 8, and yes, it tells me it's even. So notice what happened this time. This time it did the 8 divided by 2, whose remainder was 0, so that's not 1. So we go to the else part and it prints that we're even. Let's try it with the entering a 5, and it says now the number is odd. So in that case, if the remainder was 1, which was the case when it was 5, we print odd. Otherwise, we print that it's even. And there's a number of ways that we can do this. That's the beauty of computing, is there's more than one way to do it. So one thing I could say is, suppose the remainder is not 0. Then it would be odd. Let's try that out. We put in a 5 in there. The remainder is not 0, so we check to see, we divide by 2, we get the remainder, check to see if it's equal to 0. And now if that's not true, then we will print that it's odd. Otherwise, we will print that it's even. There's many variations that we could do with this. For example, we might want to change this to say, enter a positive number. And we could put a check in there. If number is less than 0, we'll write a nasty note. Error, we asked for a positive number. Now we want to say, if we didn't print an error, that must have meant that we got a positive number. So we can indent, and let's see how this works. So enter a positive number. Let's give it a negative number. It says, nope, error, we asked for a positive number. So let's see what happens if we give it a positive 3 instead. That should come out to be odd, and it in fact does. Notice what happened. We come down. The first thing we do is we check to see whether the number is less than 0. If it's not, well, if it is less than 0, we print a nasty message with an error. Otherwise, now we go and we check to see whether our number is even or odd. Python has a shortcut for this. It has ELIF, else if. We just combine the else and the if together. We leave everything else the same, simply fixing up the indentation. Now the logic is the same. If the number is less than 0, we will print an error. Otherwise, we will ask another if. If the remainder is not equal to 0, it's odd. Otherwise, it's even. And again, we can check that. If we put in a negative number, -4, nope, we ask for a positive value. Or we can ask, if I give it a +4, it says, yes, that is even. It's enough for now.